All right, guys. Anybody else need a copy of this worksheet? Oh, shit. Well, there you go, Jeff. I never learned. Sorry, buddy. I once again printed out what I thought was enough. Let me copy these down real quick, and then I'll give this to you.
PDF just equals PDF.
So last time we worked on this worksheet, we did A, B, C on the back. So we stopped at this guy, right?
Is that beta or am I dumb?
That is beta.
Yay.
Okay. So let's actually stop for a second and think about where we are at the moment, right? We kind of plowed through a lot of derivative rules. So what do we know now? We know polynomials. If I ask you to do derivative of a polynomial, how do you feel?
Great.
Fantastic. You're like, give me a lot of that shit. Just give me everything polynomial. So no, I'm not going to give you a lot. Sorry. So that's basically the power rule, many terms with the power rule, right? Even non-polynomial stuff, as long as they're collections of x to a power, plus or minus that stuff, that's easy. Okay, I love it. We also know all the trig derivatives, right? And again, if I were you, I would have sitting next to me some paper that has all the derivative stuff we know so far, the derivative of certain functions, the rules, all the rules that we've learned. I would have them sitting next to me as I do my homework. Don't get overly reliant on that because, of course, you're not going to use that on a test or something. Or a quiz, like the quiz we've got coming up on Friday. Right. What's the quiz on Friday? 3 through?
2.8 through 3.3.
Yes, basically.
Okay.
All right. 2.8 through 3.4.
Oh.
Yeah, there you go.
What's your?
Yeah, buddy. So that chain rule is going to be on this quiz on Friday.
So is chain rule 3.3 or 3.4?
Chain rule is 3.4.
Oh, that makes sense. That makes sense then.
Okay. And as I say that, I really hope I'm right. Yeah, that's a good idea. What else do we know? So we know product rule, or at least we've talked about it, right? We know quotient rule. So all of these are, we've gone through the proofs for these things, which is why we don't have to start with a limit definition for these things anymore. You guys with me? So I want to know as many, so we had to develop a few things using the limit definition, but then we kind of built with the stuff that we proved from the limit definition. We built off of that stuff. So we're sort of moving ourselves away from that limit definition. Thank God. Because that thing gets really gross really quick. Yes? Yes, it does. Okay. All right. So I just wanted us to take stock for a minute about how much we've learned. How many people are taking calculus for the first time right now? Anybody? Okay. All right. I like it. And then I know that there's several that have had some calculus before because you're all like, let me use this rule. You will in a minute. Okay. All right. All right. So we've done quite a bit, but it's all very related. They're all based off of the limit definition because they have to be, because that's what derivatives are. But since we've built some stuff that we know is true, we can build off of those. So we, like I said, we don't have to go all the way back to the limit definition. Will it ever come up? Hell yeah. We're going to use limit definition a few more times with some funkier shit that we got to prove is true, but we're not going to use it anywhere near as much as we were. Okay, I like it. Now, this stuff, good old chain rule. Let's kind of remember chain rule before we do these. These get a little freaky pretty quick. Let's just remember chain rule real quick. If I had something like this, sure, Jeff, let's start with something really, start with something nice and easy. Okay. Can somebody tell me which part of this do you not care about at first when you're about to do the derivative? Let's see if that makes sense. The E piece. I don't care about the inside shit. I don't give a shit. What function is this? Tangent of something. And I know how to take the derivative of tangent of something. Yes? Anybody? Secant squared of that thing. Yes? So the first step is pretend like this is just tangent and its derivative is secant squared of stuff. But then you have to add the link, the derivative of the inside. Okay. And again, here, don't write this down, but I want to just show you. Let me just show you real quick. We have been doing this entire time. If I just had this, what's the derivative of tangent? You just told me? Secant squared x times the derivative of the inside, but what's the derivative of the inside? 1. So we've been doing chain rule this entire time. It would have been weird to bring it up earlier until we had more of a foundation of other stuff, but now I can bring it up and I can say, holy shit, we've been doing it. It just doesn't show up unless the inside's more than just x. If the inside's just x, it's just freaking 1 for that link. Okay, really, really good. I like it. So again, chain rule, when do I use it? All the damn time. When do I care about it? When the inside's not just x. Because otherwise it's just going to give me a times 1 and who cares? So now, which part of this do I not care about now? This piece, for sure. He's just going to come for the ride. And now in here, holy shit, that one. What are you doing there, buddy? In here, I don't care about 3x plus 1. I like it. What's the derivative of e to something?
E to something.
E to something. And then, of course, the inside gets a turn. And again, do you notice how I did not have to know ahead of time how many links I'm going to have? So if your teacher taught you that you had to catch all the links to begin with, that is insanity. I kind of want to know who they are so we can have a faculty little collegial discussion, right? To me, that's just insane. That is insane. I just do them as I see that I need to do them. Am I going to have to do another link now? Am I going to have to use chain rule again right now?
No.
Hell no. It's just freaking 3x plus 1. And it's easier to see that if I just do them as they come. So now, what is the derivative of 3x plus 1? That's crazy. I'm going to bring that out front. I probably should have brought this out front, but who cares? That's all good. See, it's a little bit better to write it like this. Do you guys see why?
And you wouldn't be able to just add squared to the e3x plus 1 after the secant squared because it's not.
Yeah. Some people might accidentally put these together when this one is inside of secant and this one isn't.
Okay.
So it can't go in there with it. So it's kind of better to put it as a coefficient. You guys all see that? A lot of mistakes, very simple mistakes, are all about what's inside of a function and what isn't, because they can't interact then. Okay, so let's come back to this freaky shit. So we're going to look at part D on that worksheet. I should have written that better. Oh, well, too bad. What's a good way to rewrite a piece of that right now?
Secant beta to 2 beta plus 1 1/2.
I like it. Okay. So what is the main rule that is present? What do I have there? How many functions and what are they doing to each other? Whatever they want to, Joe. All right, be quiet. They're doing right here, so we got to talk. How many functions? What are they doing?
Two.
There are two functions doing what to each other?
I don't know what to call it, but it's 2 beta plus 1 of. Oh, it's multiplying.
Yeah, multiplying.
Oh, okay.
It's the product of two functions. What are my functions? Secant beta and 2 beta plus 1 to the 1/2. Those are two functions, yes?
Yes.
Those are multiplying each other, yes? So the main thing happening is a product rule. Now I know, you already know we're going to have to do chain rules as part of it, but I don't have to worry about that right now. So how does product rule work? And by the way, real quick, I want to make a point of this. Where did I put my prime? Here, because I didn't take a derivative yet on this line. I just simplified. Really careful. I see these little primes showing up. People think they're done before they are. So how does this work? Product rule?
So can you explain why it's product rule?
So I've got this function
Yeah.
times this function.
It's not secant of whatever that is?
Definitely not. I love it. If I took that beta out, then it would be secant of that. Right? This is secant beta times 2 beta plus 1 to the 1/2.
Beta doesn't act like an X or a thing?
No. So if I wanted to be really clear, if I wanted, let me see, where can I put this? I would have to put something around there, say that they're together inside the secant, right? And they aren't. So, I would probably write this out front. And now you see why I put that out front, that last problem we did, to make sure that nobody thought I was inside. Okay, but I'm going to be really clear about what's inside and what isn't, or at least I'm going to try to be. All right, so product rule, how does that work? Good. Take the derivative of the first dude. Leave this dude alone. Plus, leave this dude. Derivative of the other guy. So they each get a turn. Now the secant and cosecant kind of suck. I don't like them as much because when I do the derivative, I have to write a lot, right? And I don't like writing a lot. But who remembers or can look and see what the derivative of secant is?
Would it be secant beta, tan beta?
Yes, secant beta, tan beta. And then this is just sitting here. Jeff, you should have given yourself some more room. It's too bad. How does this guy work? And my betas are evolving into some different form. I don't know. I don't know what to make of that. I choose you, beta.
Let's just keep the negative on that.
Yeah, how does something to the 1/2 power, how do you do this guy's derivative? Something to the 1/2 power. The 1/2 comes down, right?
Yeah.
So again, the inside, you sort of just see it as something. Something to the 1/2. Because I only care about the outside function at first. So inside's 2 beta plus 1, that's something. What's something to the 1/2? It's 1/2 times something to the negative 1/2. And then, of course, the inside gets a turn. Can we just handle this? What's the derivative of the inside? 2. And that, of course, is where my chain rule runs out. Yes?
You lost me after 1/2.
Here?
No.
To here? Here?
Where it says plus.
Here?
Yes.
Okay, so the derivative of secant is secant tangent of thing. And this guy just is sitting here. He's got nothing to do. Plus, this guy in the second part, he just sits here. I really want this to make sense. He got a turn, and the other guy gets a turn in the next term. Is that cool?
Mm-hmm.
Okay. Secant b is just sitting there. And then the derivative of anything to the 1/2 power. In fact, anything to any power is the power comes down, and it goes down by 1.
Okay.
And then the inside derivative gets a turn that's 2. Okay, I was just running out of room over there. Lock it. If you're at home, I don't know if you can hear me over there. All right, let's see what we got. We got secant beta, tangent beta. I should have put this out front, but too bad. Boy, beta, you are not looking good. 1/2. And then what do we got over here? Plus 2. Secant beta. Well, there, Jeff. 1/2 of 2. Is that cool, everybody? 1/2 of 2 kills each other. Yay. Woohoo. Crazy shit. Just imagine if you had to do another derivative. Pretty gross. And again, if you wanted to be a little more clear, you can pull these parts out front, just so nobody thinks they're inside the tangent or something, or the secant. That's a little more clear there. Of course, when I write it, it's never really close to being clear, but that's all right. My beautiful handwriting. Okay. Yes.
And oh wait, never mind.
I like it. Okay, now let's look at this next guy. Was it this? I'm going to see if I can read my own writing. I'm fascinated by 2x squared minus 1. I don't know why. It just shows up in a lot of things. What's the inside function here? Tangent stuff. And so what's the only thing I worry about at first? Cosine. It's cosine of something. So the derivative of cosine something is negative sine of something times something gets a turn. So wonderfully vague. I love that. Here's a quote from my calculus class. Something gets a turn. Oh, that's really profound. Okay. So again, I really want this to make sense. I don't know how many people... This part, I don't give a shit about. It just comes for the ride. It's done. This derivative is done. It just comes for the ride. I don't have to think about it at all. This is the part that I got to think about. So what's the only thing I care about in this problem here?
Tangent.
Yeah, tangent of something. And of course, derivative of tangent of something is
Secant squared.
secant squared of that something. And of course, that something gets a turn. All right, let me stop for a minute. Now notice this. I'm sure you guys have noticed this. Don't we end up with like everything just kind of grows? Just a lot of shit. You've got to continuously remind yourself, what do I not care? What just comes, and what am I focused on doing something to? Right? I don't care that I'm writing a lot of shit. That kind of sucks, but too bad. But the nice thing is, a lot of what I'm writing is just done. I just got to rewrite it. Yes, maybe. So yeah, there's a lot of shit there. But what's the only part of that shit that I worry about right now? Yeah, the 2x squared minus 1. And what's the derivative of 2x squared minus 1? 4x. And I can put that out front. Is that cool? Negative 4x. And then just rewrite everything. Jeff, your line got in the way. Boom. Crazy, crazy. Oh, let me do this. Boop, boop. Okay. Maybe? So, I mean, if I had this thing up here when you walked in the room, wouldn't you kind of go, whoa, But it's because as you do it, part of it you don't care. You just rewrite it. And there's only one piece of it that you care about at a time. That's why I don't like the idea of trying to write all those links that you need from the beginning. That's insane. That's too much to think about at once. You worry about it as it comes. You only think about one thing at a time. Bam, bam, bam. Now, the better you get at this, the more you can maybe skip some steps. But I highly recommend you don't try that anytime soon. You're going to miss something. Okay. What about this one? This one seems... Well, I've already rewritten it. Is everybody cool with me rewriting it like this? Did I do that right? Thank you. Right? Power on the top, root on the bottom, like most plants. Roots are on the bottom. So go ahead and do that if you haven't done that yet. That one should be relatively easy. If you already did it, just sit there and wait. Is it Amar? Are you out there? Amar? With some? Hey. By the way, any chapter 3 that you give me today, that's going to be my focus to get graded by Wednesday, because then Friday, of course, is our quiz and that stuff. So, okay. So this one's interesting. This is like a little breath of fresh air here, right? Not much going on here. So what's the main thing that happens? Yeah, the 5/8 comes down. So something to the 5/8 is 5/8 times that something to the negative 3/8. And then the inside, what's the derivative of 7x plus 6? 7. So is that all right if I just do? Okay. So I can just bring that here. 35/8. Chua. Okay, I like it. All right. And the last one, number 2. Is everybody cool with that? You guys got it? Number 2 is a classic problem. Was anyone considering taking 178? You guys know what 178 is? No? Okay, don't worry about it. This is the one that kills people that take 178 for some reason. Yeah. All right, real quick. 178 is kind of like business calculus. It's like calculus for business and economics and some science stuff. And they don't do a lot of theory in there, which sounds great, right? But you don't have to take pre-calculus to take it. So their factoring is really weak very often, right? I'm not saying everybody in here has really strong factoring. Sorry. All right, sorry. A little burn. Okay. But here, you guys do this. I'll wait. So this is find the places where the tangent line is horizontal. How do I interpret that? What does that mean practically?
Derivative equals 0.
Derivative equals 0. So find the derivative, set it equal to 0, see how far you can make it. Oh. Speak of the devil, Iris. Oh, okay. Do. Okay. Just to make sure everybody's on the right track, what's the main rule that starts this off? Product rule, right? It's the product of two pieces, two functions. Let me write this down here. I need some more room. Alright. Kind of catch up to you guys. Good Lord, Jeff. All right. Kind of skipped a step there, right? But I mean, it's linear, so it's not that big of a deal. All right, the 3 comes down. That goes down to a second power. Derivative of the inside, bam, and then that thing is there. This thing is there. 5 comes down. That's to the 4th power now. Derivative of the inside, bam. Right, so when the inside's linear, you could probably skip writing the rule there. Let me stop for a minute. Does everybody see where everything came from there? Yes.
Why did you pop a 4 in front of the 3?
Oh, yeah, where'd that 4 come from? Anybody?
The inside.
Yeah, the inside, right? 3 comes down, that's the second power, the inside is 4. Right, chain rule, yes? Is the inside more than x? Yes. 3 comes down, something to the second power times the derivative of that something. And then that's just there.
Oh, you're not actually multiplying the equal to.
I mean,
it wouldn't matter if you did.
Yeah, this is just sitting here, and this is all from this. Yeah. Is that cool? Yeah, thank you. A little bracket is just doing what it can. Okay. So that's part of it, is just what pieces are just sitting there. That's just sitting there. It just comes for the ride. Yeah? All right, so what do we get here? We get 12 times 4x minus 5 squared times 3x plus 2 to the 5th. Let us see, we got 15 over here, right? 15. All right, let me stop for a minute. So all I do is collect my numbers, throw them out front, collect my numbers, throw them out front. And then what do we say? We want this derivative, it has to equal 0 to find the horizontal tangent lines. Which means what do I have to do to this thing? I kind of gave it away earlier. I have to factor. Yeah. All right. So how many terms are in there?
2.
Good. Because terms are separated by plus or minuses, and terms are connected within each other by multiplication and division. So this will be one term. This is the other term. What numbers? So I look at the numbers. What numbers can come out? Just a 3. Let me try to move this over a little bit. How many 4x minus 5s can come out? 2. Right? You always take out the least power because we are the semi-nice tax man. We don't take away from you more than you have. Right? So don't try to take 3 of these out because this guy's only got 2. How many 3x plus 2s can I take out? 4. Because I don't want to try to take 5 out. He doesn't have 5. And now we write what's left. So this is just what I'm taking out of both terms. What's left in this first term? Good, 4. I had 2, I took 2, they're gone. I had 5 of these, I took 4, so I got 1 of these left. So this is here after taking this out. Okay, plus what's left here? 5. I had 3 of these, I took 2, so I got 1 of these left. I had 4 of these, I took 4 of them, I got none of those left. Now here's where I get people telling me the answer is 5/4 and -2/3. But I mean, right? You got to do that. So let me see, I got 3, 4x minus 5 squared, 3x plus 2 to the 4th. See if we can do this real quick. 12x and 20x is 32x, is that cool? 8 minus 25, -17, is that right? stop for a minute.
Can you explain that?
Yeah, inside here, what I'm going to do, I'm going to distribute the 4. Hey, Ant Dude. Distribute the 4. I'm going to distribute the 5. Is that cool? Right? Inside there, wouldn't I distribute the 4?
Oh, yeah.
Distribute the 5.
And then
So I'm just
add it.
doing it real quick. 12x's, 20x's. 8 minus 25. Bam. I don't have to do a lot of shit. I just put them together. Now I can see how many places are there going to be where it has a horizontal tangent line. 3. I see 3 parts, and they all have answers. So either x, you guys cool with that? 5/4, right? Add the 5 divided by 4. Subtract the 2 divided by 3. Add the 17 divided by 32. So in my head, I'm just making them all equal 0. They're linear, so it should be easy to do. Maybe? Maybe? Okay. There's a lot going on here, right? You have to know your derivatives. You have to know your algebra. You know your factoring. You have to know your factors. You have to know a lot of shit. Yes?
I originally put I put the 5 and 3 together, so I put the 15 in front of the last 3x plus 2. Would that be fine even if I put in the coefficient at the end?
Where are we at?
Keep
Sorry?
figures in the front.
Oh, you put the 15 in the middle?
Yeah.
Oh, that's fine.
Okay.
It's just weird, right?
I just did it because I grouped it with the 5. So.
I'm with you.
Yeah.
I'm with you. Yeah, okay. We just like numbers out front so they don't get lost in
Yeah.
the middle of stuff. All right, that was exciting. I kind of, yeah, maybe. No. So, I don't know how you guys are going to feel about this. Before I talk about 3-5, I know we just finished that chain rule thing. All right, well, you guys should be excited about more practice. You really should be. So I got more practice. All right. Oh God! And this is basically like a review for the quiz on Friday. This is 3, 1, 2, 3, 4. Don't look at the other side yet. The other side's gonna freak you out. Yeah, don't look at it.
No, I didn't. A was.
Okay, look at this side. Say, don't look at it.
I mean, technically that's 2x to it's good. That's a lot.
Look at the one that says side 1. Like an old album. All right, so go ahead and just start working on these.